Okay, good morning everybody, morning attendees who are joining us, and welcome to our webinar. Rail Freight Group and Rail Wagon Association working together on this important webinar about digital automated couplers. I can see attendees are coming in now thick and fast, so we'll just give you a few minutes to join before we go live. We've got a busy agenda ahead of us today, talking about very different aspects of this work and this programme and research. We're really pleased to be working with Steve and colleagues at Rail Wagon Association on this. Rail Wagon Association, formerly Private Wagon Federation, if you knew them as that, and a really good initiative to get this forward and out to both of our members. So as we are joining, just a few bits of housekeeping, if I might. In terms of the running order for today, I'll shortly hand over to Rob Brooke, who's the head of Rail UK at VTG, but more importantly, the chair of the Rail Wagon Federation, to take us through some introductions. Then on to Steve Taylor, who will talk about the programme for digital couplers and what it means. John Brown from Greenbrier and Kurt Vetter talking to us through some of the engineering aspects. Colleagues from Ricardo Rail, Mitch Town and Stuart Kenworthy, who'll talk to us about the challenges of retrofitting wagons. And then Neil Ethel from DB Cargo and Andreas Lipka talking about the operator's perspective, the benefits of digital coupling and the experience that they're gaining through the trial programme. At that point, we're going to open up for discussion. Those of you who are attendees here today should be able to see that you can ask questions through the Q&A panel. So please do get your questions in, keep them coming. The more questions we have, the better the discussion will be. So don't hold back on those questions. If you've got any technical questions, you can also, of course, drop that into the chat function. But if you want your question in the discussion, better if you can use the Q&A. We will be recording today's session. The link for that will be posted onto our website later today. So if you do have to duck out to deal with a domestic incident or to go on to another meeting, you can drop back onto the recording later. And if you do want to have copies of any of the slides, just drop me an email later and we can get them over to you. I tend not to mass distribute the slides because not everybody wants them, but if you are interested, then just give me a shout and we can certainly send those across to you. So I think we are more or less all here now. So without further ado, let me hand over to Rob Brooke to open today's proceedings. Rob, thank you very much, and over to you. Rob, I can't hear you. Are you muted?
There's always the talking to yourself on Zoom courses, isn't there? Good morning, everyone, and a very warm welcome to this joint webinar today on what I calculate to be day 268 of lockdown. We're getting quite familiar with webinars. I think one of the great positives of what we've been through. Why is it a joint webinar? Well, the RWA and the RFG are effectively two sides of the same coin. RWA really focuses on the technical side and the RFG on the market and lobbying side. But what's clear is that both organisations, whilst distinct, have one objective, and that is focus on the enablers for rail freight growth. Hence, are working collaboratively today on this webinar. I just want to quickly thank Maggie and the team for providing the platform for this and a lot of the admin and marketing, as well as Steve, the general manager from RWA. So digital automatic coupling. Some of you may know about or heard of it. Some of you will not. And hopefully this session today will shed some light on the subject. We've got some great contributors, well, not contributors, experts on digital auto coupling, and hopefully we can learn about what it means, and more importantly, what we in the UK need to think about going forward. It is an EU programme. It's a fairly ambitious programme, which talks about a 2030 implementation date, and it's described as a prerequisite for modern digital railway. And many issues to discuss and consider, and hopefully we'll flesh those out throughout the presentations and the questions at the end. But for me, one of the major ones is it's an expensive program. There is EU funding support, but what happens post-Brexit for us and UK funding? So before I go too far, let me hand over to Steve Taylor, our General Manager at the Rail Wagon Association, to get us underway. Steve.
Well, good morning, everyone. Thank you, Rob, for that introduction. When Maggie and I discussed the subject for this year's joint seminar, we thought DAC was a good subject. There seemed to be lots of presentations doing the rounds, and it seemed a bit random who knew what. So we felt that this would be something of an education exercise. Now, since hopefully you can see my slides now, yeah. So since then, and looking into this in the last couple of months, I'm convinced it's far more than an education exercise. Today really should be a bit of a wake-up call to us all in the UK, and a wake-up call which should be followed by positive actions. So why do I think that? Does it matter? But in Europe, work is racing ahead. They have 7 work packages with 40 work streams actively at work. These work streams cover technology operations and standardization, testing and pilot projects, migration, system capacity, costs, business case financing, communications and IR. And the 7th package is called Intelligent and Automated Freight Train. And they're already in the position where they are talking about choosing the preferred solution by mid-2021, so that's 6 months' time. And we obviously will have had no input into that. And I guess we'll hear more from Neil and Andreas later on that trial process. It is a Shift to Rail project. Shift to Rail is only funding the Secretariat so far. And there's recognition that it's a huge challenge in Europe. 600,000 wagons to convert or replace. And for us, this will become a reality in that international wagons fitted with DAC will be coming through the tunnel, definitely from 2030 if the timescales are kept to, and probably before then. The EU has also drafted changes to the Wagon TSI, which would be implemented in 2022. Now, there are lots of proposed clauses, but these 2 are the ones which get to the heart of the matter. So the first one, the transitional measure. Wagons fitted with manual end coupling are allowed to be placed in service during a period ending on 31st December 2025. So this means that a wagon with a manual coupling, the present screw coupling, will not be allowed to enter service in 2026. So given that projects are 2 or 3 years in the gestation and delivery, if you're thinking of new wagons in the next few years, you've got to take this into account. And then the second clause, which I think is significant, is basically saying that after 31st of December 2030, only freight wagons fitted with automatic couplers shall operate on the network. Now, of course, we have Brexit, whatever you think of that. I was hoping the DFT interoperability team would join us today, but they couldn't because they're rather busy with things for 1st of January. but they have approved the words on this slide, so I won't depart from the wording. But the UK government position is not to stay ever aligned with new TSIs, but there is a strong incentive to do so in relation to international services, and our obligations under COTIF will almost certainly require us to follow the TSIs. In a domestic context, the regime gives us flexibility to diverge from TSIs if that was in the UK interests. There isn't an ambition to diverge for its own sake. So the DfT would look to industry to make the case for why divergence was beneficial. So if we don't want to have digital automatic couplings, we need to go through the DfT RSSB divergence process to achieve that. So the default position is that changes to the TSIs in Europe would be reflected in UK regulations unless the industry decides otherwise. Now, the RSSB DfT process is set out in a short document and a PowerPoint presentation, but it's not yet formalized. And this is something we've been talking to DfT and RSSB about. They say the timescale is 9 months. They know, I'm not saying anything I haven't said in front of them. I'm highly skeptical on that 9 months, and I think it could easily be 18 months. So if this TSR revision is coming in 2022 and the divergence process is 18 months, there ain't a lot of time. So that's why I think today is more than just education. I think it's time to open the debate. Now, it's easy to say for us, it's not needed here. There are clear differences between the UK and the European freight markets. There's more wagon load traffic in Europe, more shunting, marshalling, joining, unjoining, coupling, uncoupling. And what about the cost and the chaos of implementation? I guess we can all imagine what it would be like to have locomotives and wagons with both types of coupling running round at the same time. As my son used to say when he was a lot younger, it will be chaosity. But if we do reject digital automated couplings, we forgo any potential benefits such as safety, efficiency, and we fall behind Europe technologically. Once you have DAC and there's a data line running down the train, there are lots of possibilities. For example, your wagon could be fitted with a derailment detector, a vibration detector, which would instantly send a message back to the driver, stop and examine your train. You know, the days of a derailed wagon ripping up miles and miles of track should be gone. And then if you do that, well, why not something else, a hot wheel detector or an axle heating detector? The possibilities, I think, will just multiply once you've taken that step. But if we say no, we will fall behind, no doubt at all. And what about ETCS? So if a wagon can tell the locomotive, I'm wagon number 123, my length is 60 foot, my brake force is X, etc. The collection of data for ETCS could be or would be automatic. Now, there are people who know far more than that about that than me, who can contribute in the debate afterwards, but it's got to be a building block there. So in summary, I think we need to understand the issues. We need to understand the costs and the benefits of DAC. And we need in the UK to get our act together and determine our way forward. And I hope that today is the first step. So delighted to welcome now John and Kurt from Greenbrier, who are going to tell us more about this technology. Thank you very much.
Thank you, Steve. Firstly, good morning to everybody, and a thank you to Maggie, Rob and Steve for allowing me the opportunity today to speak about the digital automatic coupler. Let me just get my screen up. Let's share screen. Okay, can you see that? Hopefully, yes. Okay, let's just move that. So, for those of you who don't know me, and I've seen many of the participants, my name is John Brown, Sales Director for Greenbrier Europe. We are one of the leading designers and manufacturers of freight wagons, both in mainland Europe and the UK. Our typical annual production would be between 3,000 and 4,000 wagons pan-European. So one of the big volume producers in Europe. Just a quick overview of the presentation, and I apologise if I'm going to repeat some of the things that Steve has mentioned, but I was really just going to give a background on who is driving this, the key players, and what the aim of Europe is. What is the digital automatic coupling, the equipment that's on the market today, wagon design, benefits for the design of the industry, costs, challenges and timeframes. A lot of these at the moment are unknowns, or they will change. It's a moving target. It is, as Robert mentioned earlier, I think a very ambitious programme, one that will cost huge money. But for all of the reasons that Steve has mentioned, the momentum in Europe is now on a large scale, with many working groups, demo trains, research and development. So we need to understand as a country and as an industry where we are heading in the UK. So who is driving this? Well, from what I understand, it was an initiative from the TIS Group and the Ministry of Transport and Information in Germany, the BVMI, who considered the DAC system as one of the keys to make the rail freight industry fit for the future years. Out of this rolled a consortium which had been established with the EU Freight DAC delivery programme with the following industrial partners: DB Cargo AG, who are the leader, VTG, JCheck Semeva, SBB Cargo and Rail Cargo Austria. Their aim was to have a single sector-wide digital automatic coupling system, not just the manual type. And as I said, today, information and knowledge is being gathered through questionnaires, working groups with the state railways and the DAC group. Further into the project, couplers of today's level are being used, but I also I understand they're being used today. They're being trialled, they're being tested on wagons from SBB and others. And I think Andrea, you probably know a lot more about that than I do, so I'll leave that brief. In parallel, screw couplings are to be used, but with the goal to migrate the 600,000 wagons that I discussed by 2030. I have also read figures that could be slightly lower than this, at 400 to 450,000 wagons, and that depends really on the business case, as certain wagons will come closer to the end of their design life of 40 years. Does it make sense to spend whatever the amount will be on retrofit? But either way, whether we talk about 400, 500 or 600,000 wagons, it's a huge amount and it's a huge programme with many challenges. So what is DAC? In particular, this is DAC 4. There are different levels: DAC 3, DAC 4, DAC 5. This is DAC 4. This will allow, as of today, the same as the screw coupler with the air power for brakes and pneumatics. However, it will have an electrical supply, 110 volts, I believe, electro-pneumatic brakes, or the EP brakes as I call them, and a data bus supply for telematics and communication. So really, by enabling a continuous power and data line across all freight wagons, DAC is essentially a building block for the digitisation and the automation of rail freight transport for the future. Just a quick couple of photographs. On the left-hand side, see the standard draw hook and screw coupling. That system has to work with the buffers. So again, you have the two pairs of buffer there for the push-pull loads, fully manually coupled, uncoupled. Same with the single or twin brake pipes that we have in the UK. On the right-hand side, we can see a digital automatic coupler. It looks a lot more complex with the different cables, air supplies. You'll notice no buffers. And looks considerably more expensive. So the equipment that I'm aware of that is available today, 4 producers, Delner, Voigt, CAF and Wagtec. Currently, you can see from the 4 photographs, they all look different. 3 of them actually do have different coupling heads, so the interchangeability there, as far as I'm aware, doesn't work as of today. The length of the system are all different. Again, there needs to be a standard length or ways to be able to accommodate those into the draft pockets. So the aim is to have one coupling type, and that must be selected on the way to the European standard. I think there'll be challenges on how they do that, but again, the industry needs one system. We can't have like the olden days of VHS and Betamax. We need one system. So for new wagon designs, I will touch on some retrofit, but for new wagon designs, the critical area here is what I call the draft pocket. And historically, Greenbrier produced these in accordance to UC 530-1. This is an old standard that goes back to the early 1970s and basically sets out the dimensions for the width, the height, the length of the pocket area, which we can see down here. Nominally the length from the headstock to the backstop, which is required for a digital automatic coupler, but not required for what we use today, is 1505 millimeters. Typically the draft gear that we use today is approximately 870 millimeters. Thankfully, from what I've seen, all of the coupling lengths on the new digital automatic couplers are less than 1505 millimeters. So for new wagon designs, they would fit in there. And certainly for past wagon designs for mainland Europe that we developed, and also for some wagon types in the UK, they have that same dimension. So the actual equipment should fit in there. However, what would need to be looked at is this back draft stop here, and along with sort of preparation holes that we can see in these areas. So I do believe that's all retrofittable, but obviously there is work to do there. So in general, future UK wagon designs, future, not present, not past, are okay. I use excluding intermodal wagons. That's not fully true, and I'll come on to that a little bit later. But what we can sort of see here is two systems. Firstly, the intermodal wagons, you can see the draft gear is sat proud of the deck height. So in fact, this area here, which is normally about 700 millimeters, is underutilized or wasted space because your container spigots would then be located as close as possible to this. And then you have whatever deck length you need for whatever containers you're transporting, 20, 40, 45, 60, etc. in the UK. For general bulk wagons like box wagons or aggregate hoppers, pole hoppers, biomass, etc., the deck height isn't as critical. So like the conventional European wagon, the draft pocket is built into the end assembly, and the draft gear, or in this particular case, the automatic coupler, would be located below the deck. So would not be infringing on whatever the load is that you're transporting. Also, if we look at the end of the wagon, the headstock area where you accommodate the buffers, typically in the UK, we have this configuration, which has a smaller mouth opening. And that was simply because nobody ever believed in the automatic coupler over the years, although we did fit some to the EWS wagons back in the year sort of 97 to 2000. It was an American system. But because predominantly we don't use it, this arrangement is cheaper to manufacture, it's stronger, and that's what we have. If we look at mainland Europe, you can see the opening here is significantly different, and this should accommodate maybe the digital automatic coupler. I have seen ones in Munich and Berlin at the exhibitions where there needed to be further modification around this area. But I think the main thing from the UK is that this whole area under the wagon should be able to accommodate the digital automatic coupler. So just a little bit about the intermodal wagon. And I'm showing here basically the explanation of why it could be a problem. We have to have a deck height in the UK of 980 millimeters or lower in order for us to transport just the standard 8'6" container. If we have a deck height that's higher than that, obviously we then start to infringe the W6A gauge. So for this reason, and due to the standards out there regarding buffer heights and the coupling heights, this needs to be mounted higher than the deck, or sat proud of the deck, so we have a wasted space. So again, for new wagons shouldn't be a problem. You know, we minimize this area as much as possible, and then we put the container spigots as close to this draft pocket in order to minimize the wagon length, and therefore hopefully allowing the customers to have more wagons on a block train. If we have a new dimension here, and I believe we will, but I don't know what that is, then obviously for a new wagon, basically the 40 foot, the 45 or the 60 foot container wagon would become longer over headstock length by whatever the difference or the delta is between the current draw gear and what the new proposed will be. There is a way to minimize lengthening the wagon by using drawbars, but that would ultimately mean you then need to operate twin or triple wagons, which operationally sometimes is not always the preferred strategic option, because if you do have a problem with a wagon, you end up taking 2 or 3 wagons out of service rather than 1. But it is possible. So the new wagons would potentially be longer. Now, retrofitting wagons, I do see a big problem here, or if it is possible, huge cost, because you have to lengthen the wagon. And that's not an easy process in its own right. And certainly for some of the container wagons, and some of our designs are of this nature, I call a spine wagon without riggers. It's very difficult then, once you've lengthened it, to actually move the position of the container locks, because they're sat on these outriggers. So this is the, let's say, the product group that I see the biggest headache with in the UK. And the 60 foot wagon, it's too early to say yet, but certainly we believe you wouldn't be able to operate the auto coupler with the buffers in the transition period, because this wagon is on the edge of passing standards with regards to the forces when the wagon goes around a curve. So further review would be needed there. The other thing to add, and I don't see a big problem with this, but again, it depends on the wagon type. Obviously, we've mentioned there's going to be power lines and bus communication for the telematics, etc. All of that cabling is going to need to be routed from one end of the vehicle to the other. As I say, normally with things like box wagons and intermodal wagons, that isn't a problem. You can route it under the underframe. When you come to the hopper wagons that we typically operate in the UK with bottom discharge doors, that becomes a little bit more complex on how you route it. But in the past, we've managed to do it with the air supplies. So it just needs some careful thought from my engineers. So key benefits for the wagon: possible reduction in tare weight by up to 300 kilograms. This can lead to possible increases in payload for some wagon types. Some maybe not if they're a given volume, like tank wagons, etc. But potentially there is an opportunity there to reduce the tare weight and increase the payloads. Electric supply, again, this can be endless. Refrigerated containers, I'm not sure. Lights, control systems. As Steve mentioned, I think once people start thinking about this, then really the thoughts on electrical supply and data communications can be endless. EP brakes, giving almost immediate brake signals to the complete train, unlike today's pneumatic brake system, where basically the wagons at the closest to the loco start to apply the brakes or release the brakes first, which in some cases we know can overbrake or underbrake, causing wheel slides, etc. With sort of fly-by-wire, I suppose it is. I'm not sure exactly what EP brake is, but I understand it's the electrical signals that basically send the signal into the brake system to apply and release the brakes. Additionally, automatic brake testing. I suppose you could also have wheel slide protection. I know that has been out there, and we certainly trialed it 15 years ago. But again, anti-lock brakes on trains, almost enhanced. And again, data communications for further development of telematics and digitization, which certainly has picked up huge momentum in Europe in the past 2 years. I would say now, of our 3,000 to 4,000 wagons we build annually, all of them are prepared to accept our customers' chosen systems. We don't actually fit them to the wagon, but we put all of the supports and the conduit, etc., in place, and then the customers fit those systems afterwards. But certainly they're huge programs in Europe, I think, from all of my customers, all of the big leasing companies, etc., to have these fitted to their wagons. So some key benefits to the industry just generally, because I know other people will talk about this. Obviously, you know, it goes without saying, a reduction of manual shunting work, coupling and uncoupling wagons, which has to lead to lower risks for the shunting crew, along with better working conditions. The ability to compete more successfully with the road, leading to an increase in transport share as new market segments might open. Increased system speeds, again, just everything to do with coupling and uncoupling, and the formation of trains. And again, depending upon with the sensors for the telematics and the digitization, this should enable condition-based maintenance, which would lead to a reduction, I think, in maintenance costs, plus an increase in wagon availability. So it all sounds good until we get maybe to this page. As of today's knowledge, and this is just myself asking some suppliers at exhibitions what these systems cost, and this is based on a new wagon. You know, a pair of these couplings, we're looking at in the region of €20,000 per wagon. However, the studies that I've read and that I've taken information from have identified sort of €10,000 to €15,000 with the aim to be as low as possible. And based on that, the whole project on 600,000 wagons requires, you know, somewhere in the region of €6 billion for the European fleet alone. Retrofit of wagons, well, that's included in there, but for me, I think the cost of a retrofit is going to be even more expensive, because you've got to initially buy the equipment that we would fit on a new wagon, but then you've actually got to retrofit it and accommodate it and cut and shut and do whatever we do with different wagons. So I think, you know, as of today, these figures are a strategy and a concept, and I understand more accurate details will be produced after 2022. I think it's fair to say one of the assumptions that I'm hearing from a lot of my customers that are involved in the consortium, there's assumptions based on the fact that currently the production volume of such components is relatively small, and therefore not as efficient as it could be. Therefore, you know, if we can suddenly, you know, they're going to have to produce kind of 100,000 plus 200,000 couplings a year. That volume production should lead to cost efficiencies in the supply chain and drive the cost down. So the challenges which lie ahead, obviously, technical design and testing. I think easier for new wagons rather than retrofit. Homologation of new, and I say homologation, testing, approval also of new and retrofitted wagons, along with current existing approved wagon designs. You know, some of the designs that we've produced in the last 2 years, our customers asked us to modify the draft pocket not to be AC supplied or AC prepared, because of certain gains you can get on a wagon by not doing so. So I'm not, you know, with 500,000 plus wagons out there, plus the 10,000 to 12,000 new wagons we deliver every year as an industry, how much approval work is there going to be? You know, obviously a new wagon needs full approval, but does retrofit need less? Does it need to go to the notified bodies? I don't know, but, you know, labour capacity within those organisations. Then you've got the regulation of standardisation and what the TSI definition is going to be. Financing, you know, the business case for the digital auto coupler in Europe, possibly EU-wide funding, and I think, Steve, you touched on that. Maybe some offers from the big stakeholders. Production capacity for DAC system, not wagon production. We don't see wagon production increasing. That just goes up and down with market demand. But if we're looking at retrofitting even 500,000 wagons in 5 years, 6 years, you know, we're looking at 100, 200,000 coupling systems, which typically, you know, if we look at screw couplings, would only be 20 to 30,000. So production capacity for DAC system, yeah. And then obviously all of the other sides to do with operations, standard processes, safety, training, and the migration planning of converting the existing wagons. So all of these will require huge coordination at an EU-wide level. And the last slide I'm not really going to go through, but it was some time frames that I've taken from the Ministry of Transport in Germany, and it's just sort of breaking those down into technology, operations, finance, and regulation, which were kind of the things that I discussed. But as you can see, for the first 2 years, from the beginning of this year until the end of 2022, there is a huge amount of activity happening. and then obviously the rollout from sort of that information happens later, 23, 24, up to 2030. So yeah, thank you for listening, and I'll be happy to take any questions at the end of our presentations.
Okay, do you want me just to crack on?
Yeah, you can do, Stuart. Sorry, I thought Steve was going to do that, but no problem. Yeah, Stuart, I was actually in fear then. I thought when I looked at that screen and I saw all of these people on mute, I thought I haven't just done that full presentation on mute.
John, you were fine. It's no problem. You were perfect.
Caught me napping there. I was just writing some notes from some of the chat questions. So Stuart, thank you very much, John. So it's over to now Mitch Town and Stuart Kenworthy from Ricardo to go through with us some of the challenges of retrofitting. Thank you very much.
Okay, hopefully my screen's coming through all right. So a quick overview of Ricardo. Ricardo, a global engineering company with presence in a number of sectors, including rail, automotive, engine, environment. We have expertise in decarbonisation, engine systems, safety management, and approvals, to name but a few. So you've got Mitch Town's going to run through some of the problems that we might face when retrofitting digital autocouplers, and I'll touch on what we believe the approval process would entail for the retrofit program. So Mitch, are you?
Yep. Okay, guys, you can see the title of this slide is all about retrofitting on wagons. And just first, okay, again, next one. First message to get across, I think that's relevant, is we do have some auto couplers already in this country, and the type is a non-rigid. So the difference in height of the wagons on something like a Buckeye that's fitted to some of our wagons is accommodated by essentially a sliding fit between the two coupler heads. But the digital auto coupler needs to automatically couple communications, essentially air, the data bus line, and so on, and therefore it will be a rigid coupling, more like what is fitted to passenger vehicles. And the reason that's important, next one please, Stuart, is because it brings about some additional challenges. So the coupler head needs to be supported in order to hold it roughly in the right horizontal position before making a connection to the adjacent vehicle. And that's the green structure you see in the diagram here. Our wagons at the moment do not have the space or the capacity for this. But just generally looking at the anatomy of the coupler, so the main bit, the bit we're probably mostly familiar with from looking at wagons, is the coupling head, and then there's a locking or connecting mechanism that engages or disengages. So you can see those items in blue and red. But the really important thing on this diagram is, as regards retrofitting, the spring damper system at the back. Now, our buffers at the moment take the longitudinal compressive forces, either from a small impact at the point of buffering up or whilst in service. Well, if the auto coupler is going to be doing this, then that spring damper and all that energy absorption now needs to be behind the coupler. And that has some space challenges. So next one, please. Now, our friends across the continent have been, as John alluded to, largely taking cognizance of something called UIC 530-1. It was introduced in 1974. I don't have an English copy of this. The one you can see is a French copy, and the translation below there on the right-hand side, it's the constructional conditions for wagons to be observed with a view to fitting the automatic coupler of the member railways of the UIC and OSGD, respectively. So this idea has been around for a while. And again, as John alluded to, a lot of the wagons that they design, as particularly for Europe, have been incorporating the space that was originally envisaged for this. But here in the UK, we have not We have not really taken any notice of 530-1. That's possibly why I haven't got an English copy. And why not? Well, even if we look at the Wagon TSI since 2006, that was mandating screw couplings. There was nothing in there taking any notice of the digital auto coupler and its impending arrival. So if we just work to the TSIs, which we've done, being UK centric and somewhat blinkered to the UIC rules perhaps, then UK designed and manufactured wagons have tended not to have this facility incorporated. John alluded to the fact that Greenbrier, because they actually have a broader focus, they've incorporated it on some of their wagons, and therefore potentially they are more ready to accept the digital auto coupler. So there's a few ifs here. If after 2030, in accordance with the information Steve gave us earlier on, in 2031 and beyond, if you want to use any of the wagons that you have running around today that have conventional couplings, if you want to use them beyond 2030, then potentially you're going to have to retrofit the digital auto coupler. Next slide, Stuart, please. So what does that mean? John has already said you need more space, and there's actually two potential types as well, and one needs a little bit more space than the other. On the left-hand side, the vertical support or suspension is provided by some separate structure which requires further modification to the headstock to provide the space for that structure. There is a second type which would appear to require slightly less modification, where the support structure, if you look at the bottom right-hand side diagram, the support structure is incorporated into the new installation. So there's potentially slightly less effort required to modify an existing wagon. But nevertheless, whatever happens, there's a significant amount of space required behind the headstock for this additional damping or shock absorbing system that has to be incorporated behind the coupler. Next slide, please, Stuart. This is an extreme example. So for some wagons, maybe that space is there, maybe it isn't. It depends how close you are to the bolster and things like that. But where it is immediately apparent that there's a problem is the container carrying wagon. And this is just a scaled comparison and how much extra space is needed. And John's already suggested to us that's about 600 mil or so, yet to be known. But this would be a big hit for a container carrying wagon, and modification would require essentially the end of the vehicle to be cut off and a new one fitted, with all that entails cost as well as loss of wagon train length and so on. So next one, please. I was worried about the length in front of the headstock, but it seems the impact of that is not so great. Our screw coupling system at the moment is, the coupling plane's at about 620 for a 620 buffer projection, and the auto coupler, it looks like it's going to be at about 645. So 25 millimeters per wagon, 50 millimeters per wagon pair doesn't seem too bad. So all of the issues seem to be behind the headstock. Next one, please. So this is really to get you thinking about the challenges if you want to be running older vehicles past 2030. The introduction of a bar coupler or this auto coupler actually brings additional derailment resistant challenges. There is a Euro norm out there which deals with propelling forces, particularly on a reverse curve, and introducing a bar coupler or an inline coupler in the center of the wagon compared to side buffers does introduce an additional propensity to force the guide wheels off the rail by flange climbing. So if you're designing from new, you can take account of that. If you're retrofitting, your bogey centers are already set, and that would add to the challenge if we have to move the bogey centers as well in order to comply or get satisfactory derailment performance. The other thing of interest is that it's a good thing. The couplers are going to be stronger. It seems something like 1,500 kilonewtons tensile, but 2,000 kilonewtons compressive will be their strength. But that is essentially the loads that we designed the underframe to. Now, 2100 requires that and quite sensibly, the coupler acts as a fuse in the system. We would rather break the screw coupling than tear out the end of the wagon, much cheaper to replace. But if we end up with these digital auto couplers fitted, they may be as strong as the wagon, and in some cases potentially stronger. So now it's the wagon that will be damaged in an extreme case. So the rest of these just really throwing those thoughts out there. Will we have to apply this change to intermediate couplers, bar couplers between wagons? I think not. I think the idea is it's to ease shunting and regular wagon changes rather than those between the wagons. I think that wouldn't be the case, but I don't know. Will the change apply to existing auto-coupled wagons? So there are a few out there. For example, the swing head Buckeye that I think is still around to an extent. Another one is fire risk. So we're now potentially got an electrical signal passing down the train, and is this an issue for a fuel tank wagon or a biomass wagon? I think in the end it wouldn't be. Obviously, we designed the installation such that it wasn't a threat. And as John alluded to, routing the air and electrics down various vehicles would have different challenges depending on the vehicle type. And I'm sure there's plenty of other things out there as well to think about. So that's it for me. I'm going to hand over to Stuart now, who will talk about the implications on acceptance.
Yeah, so I thought I'd touch on the authorization process as it stands today, recognizing that there might be changes coming in the 2022 issue of the Wagon TSI, which could render all of what I present somewhat redundant, but based on current information from today's TSIs, the end coupler is a basic design parameter within the TSI. So any changes to the end coupler mean that you need to consult the TSI. Changes to wagons that were registered pre-January 2025. There's a requirement to move in the direction of the TSI, recognizing that the vehicle itself might not be TSI compliant. In particular, the Wagon TSI reverts to the lock pass TSI for definition of ICs, and we'll come on to that in a moment. So the Wagon TSI doesn't mandate auto couplers, as Mitch already mentioned, and it doesn't list it as an IC. However, as Steve mentioned earlier in the presentation, it is likely to be added as an IC in 2022 and mandated from January 2026. As I mentioned earlier, if it does become an IC and you're retrofitting it to a wagon pre-January 2015, I think it would be a rational conclusion that if it is an IC constituent that you're putting on the vehicle, that it would be moving towards TSI compliance. If you look at auto couplers as it stands, they're actually listed in the lock pass TSI, and therefore any changes to the mechanical coupler would constitute a need to reassess the IC, and it would be assessed in accordance with EN 16019. Some vehicle level properties for couplers, they're somewhat few and far between really. Just giving a bit of definition around what an end coupling is and inner coupling. And the really pertinent one is the requirement to meet the buffer loads of 12663, which Mitch brought up earlier. So when you're making a modification to a unit, there's a requirement to consult the list of basic design requirements or parameters. So if we take the end coupling that we discussed earlier, section 3 and 4 define effectively the level of scrutiny that it's required. Under 17A, a level 3 change drives you in the direction of Directive 2018-545, getting mixed up there, and in particular clause 15.1c, which states that as it stands at the moment, the change to a end coupler would not require reauthorization with the OR. So in summary, the TSI as it stands at the moment wouldn't mandate a reauthorization. However, there is Article 21.12 of the Lock Pass TSI, which is also captured in the Wagon TSI, which looks at overall safety level of the vehicle and if it's adversely affected. So when you're doing your CSM significance decision and following your SMS, if at the end of the process you've identified that it would adversely affect the overall safety of the vehicle, then you would need to actually get authorization. So that's the authorization process. That said, with the need to go to the OR to get the vehicle authorized, you obviously get the certain level of assurance that it's had a good level of scrutiny, but the authorization process in itself would just add on to the project program. I mean, you might be looking to at 4 to 6 weeks additional to the project timescale to get the vehicle authorized, depending on the OR workload. Assuming it doesn't need to go through well, either way, you're going to need to go through an approval process. So post 2015, you'd need to get the notified body to update the certificate for the pneumatical and mechanical components. And pre 2015, if you're installing the digital auto coupler as an IC, then it would need to be assessed against the TSI. But integration against the assessment party standard, which is RIS 2700. So we've had this in the past where we've had a client who's fitted a automatic coupler to the vehicle, and the automatic coupler was assessed as an IC, but the integration into the vehicle was assessed under assessment party. Due to the nature and the severity of the change, I think it would be prudent really to follow the NOBO-DEBO route as far as possible. Your safety management system and CSM significant decision would dictate the need to appoint an assessment body, but I think anybody looking at this change to the safety related component would conclude that it would require an assessment body to assess a change. So what we've considered really is only the digital auto coupler. As some of the other presenters have touched on, there's a high likelihood that there will need to be a number of other modifications to the vehicle, new electrical lines, new data lines. As Mitch touched on, significant structural modifications to the headstock and lengthening of the vehicle. So they in themselves could constitute a significant change in the requirement for the vehicle to go through the authorization process. One little subtlety from the Wagon TSI, Appendix C covers the brake pipe interface requirements, which will be affected because you're moving the interface location. But ERA have already been consulted about this, and they've advised that you could use CSM to cover the risks and no additional authorization would be required. It's worth noting that Appendix C that covers the brake pipe requirements is optional. However, if you've previously applied it, then you'd need to apply it again. So there's the approval process at the moment is one route. The impending changes in the 2022 Wagon TSI could drive a number of additional changes, but I think the important and pertinent point to note is whichever, whether it needs to be authorized or not, you're going to need to go through an approval process. And given the timescales involved, I think it's worth recognizing that that could add on quite a bit onto the back end of the project in the region of a few months. And let's say the scope and duration of that assessment is really going to be dictated by the amount of modifications that you need to make to the unit to accommodate the digital auto couplers. So that's all the slides that we wanted to cover, Steve.
Okay, well, thank you very much. So we've heard from John, Mitch, and Stuart about the engineering side of this. Now I'm delighted to welcome Neil and Andreas from DB, who can tell us about the operational aspects. So thank you very much, Neil.
Thanks, Steve. Hi, good morning, everybody. I think Steve mentioned at the beginning of this that this was also an opportunity to be educated, and certainly from my perspective, you know, I'm learning a lot of things about it. But thankfully, working for a company such as DB Cargo, we have a far and reaching European colleague network. So my colleague from Germany, Andreas Lipke, who is the head of migration for the digital automatic coupler, has joined us with his expertise to share with you all. So Maggie's going to run a little video to start off, and then we'll hand over to Andreas to do the presentation, and I'll act as a supporting role for any questions which are relative to the UK in particular. So over to you, Maggie, for the video, please.
Thank you. Right, let's see if we can make this play. Give me a thumbs up if you can see that, someone. John, brilliant. Thank you.
Okay.
Right. So
Good.
we're going round again then.
Yes. Thank you, Neil. Thank you, Maggie. So as Neil already mentioned, I'm Andreas Lipka from DB Cargo, based in Berlin in Germany. Steve was in the very beginning this morning mentioning the European Dak delivery program under the umbrella of Shift to Rail. And he mentioned there are 7 work packages, and I'm head of the work package 3, which is focusing on migration. What's about it? I could detail a bit out more after the slides if there are some questions about this. So fortunately, most of my content was already somehow presented. So what you can see here is an overview of the benefits for all involved European railway actors. And if you see the stakeholder groups, we have here the infrastructure managers, the RUs, we have the wagon keepers, the manufacturers, of course, and in the end, the customers, the shippers. And the benefits, for example, for infrastructure, you have the train integrity message. Yeah? One of my predecessors already mentioned the wagon is identifying itself to the locomotive and says, I'm there, I'm still there, I'm still there, and my wagon number is number 123. And so the infrastructure managers can on the long run reduce a lot of their equipment at the track, because everything that is checking the train integrity can be in future done by the train by itself. The RU, of course, has many benefits from different perspectives. You have less shunting, you have higher capacity, you have some some benefits from sensors, from all these nice telematic tools and toys. Just imagine, we've heard already something about telematics on the wagons, but imagine a temperature sensor on the wagon combined with the timetable and the weather forecast. And then you could predict the temperature inside of the wagon tomorrow when the wagon will be somewhere. So there are many benefits from an IU, and I'm sure there will be some things found we are not even thinking about it. For the wagon keepers, it's also pretty easy. They can offer much more equipment on the wagon, smaller sensors about wagon condition-based maintenance of the wagons. Sorry for my poor English. The manufacturers have, of course, much more to offer because a wagon will become much more intelligent, and the shipper will sooner or later integrate all of that in his own logistic offer. And the overall benefit, I think, is railway as an industry will become much more intelligent. And the most important in DAC is the D, not the C. Coupling is maybe a topic. Yes, of course, you could reduce shunting efforts and so on, but the digital and automatic aspect of that is much more important. Next slide, please, Maggie. You know the old world, and you've seen already in the presentations several pictures, and also in the movie how it will look like in the future. So we will increase the efficiency by reducing the inefficiency. Coupling and uncoupling will become less time consuming. And also for the ground staff, you see many benefits because it's on the first hand physically less strenuous. If you have to lift a coupler today, you have to lift 35 kilograms. So this is quite a thing. And in future, you have much less to do than there on the track. By the way, in Germany, the trade unions are supporting the DAC implementation due to the reduction of labor accidents, of work accidents. Of course, they understand that there's also an idea of maybe reducing the one or other guy of the ground staff. Yes, but by the way, being a member of a shunting team is also not that attractive job. And if they have on the other side more interesting jobs in the workshops, for example, you need there some electricians more than in the past, or you have IT on the wagon, this will make railways much more attractive from their perspective. So trade unions are supporting us here. This is very important for the sector. Next, please. So what we can see here is emphasizing even more the aspect of that not the coupler, the DAC itself is the interesting thing. The interesting thing is that it is an enabler for almost everything you can imagine in 2020, 2021, what you can do with a rail car. And the wagon and the locomotive can communicate with each other. The wagon is telling something about his cargo or about his own condition or about I'm the last wagon in the train and whatever. So this is, I think, for daily operations worth to be discussed deeply from an RU perspective, of course, also from a workshop perspective, but especially for RUs. Think far beyond coupler. The DAC is not just replacing the old screw, it's much more. And next slide, please. So we identified, this was a bit based on funding by the German Ministry of Infrastructure. We did several pre-studies. we identified a total of 28 use cases for the DSC, and you can group them in 3 clusters. The first, of course, the increased efficiency. So you have stronger wagons. You can run longer trains. In Germany, we are currently testing 860-meter trains. We are intending to run sooner or later, as the Russians are already doing this with their old AC SA3 type of 1,500 meters, which is double the length we have today. Today we are running 720, 750 on some lines, not everywhere, but in some lines. And we try to double it sooner or later. So this is, I think, much paying into utilization of a train. Then I already mentioned the second cluster of use cases is on automation and the DAC as an enabler. For example, regarding brakes, one of the questions in the chat were about self-braking after uncoupling. You can see this already in Switzerland. The Swiss SBB Cargo already tested and implemented a smaller version of this automatic brake testing and braking system in some 100 wagons 2 years ago. So this is already happening. And of course, you have a third cluster of benefits you could summarize under security and personal and market potential topics. And work safety is one topic. More attractivity of working in a workshop, for example, or being a railway employee is not that much dirty anymore, is an argument also you are interested in if you would like to recruit new people to your RU. Okay, this as a brief overview. Thank you, Maggie, for the presentation. I think we can step out here. So if there are immediately some questions, we could raise them here, or we put it at the end. Steve, I think we gather all the questions in the end, but if there's something to be better understood, maybe now.
Yes, okay. So Maggie, I think you're going to take us through a period of discussion looking at the questions. Do we have any which are immediately relevant to Andreas? Otherwise, I think we'll go into a general session.
Yeah, well, we've had quite a lot of good questions in, so I think let's move into a Q&A session and dive into those. But I mean, first, if I might, a couple of observations for me. Firstly, thank you to all our speakers there for some really interesting presentations. And I think, you know, there are some comments in the chat which are kind of going, well, why should we do this? What's the benefits? And, you know, I think when I listen to Andrea at the end there, it seems to me the question is, we absolutely have to do this. How do we make it a positive business case? Because, you know, increasingly, if you are not digitally enabled, you aren't really earning your place at the table anymore. And I think probably our first speaker spoke about it as being a data line running down the train. And I think as a description, that's almost more grabbable than digital automated couplers, because as we say, it's not about what joins the wagons together, it's the data passing down the train and the opportunities that gives us in a whole host of spaces. But nonetheless, it's clearly not going to be the easiest thing to do, or indeed the cheapest. So let's dive into some of those questions then and see. So what I'm going to do, I'm going to go from the top. So if I think we've covered one, we will skip it, but otherwise let me read them out. And just, I think unless it's directed at one of you in particular, just dive in with your thoughts. So one in from Matt Dyke. As an innovative equipment manufacturer, we're excited about the innovation opportunities DSC can enable. We see this as a major development and keen to work with manufacturers and operators making the shift. How do we as a supply base help associations drive this forward instead of waiting for a pull from a customer? Steve, do you want to pick up on that one, perhaps?
Yes, I think this is a very important question. Certainly, I think bodies such as the RWA will be looking at what are the benefits, what are the opportunities, as well as what are the costs. But the challenge we have is we're a very fragmented industry, and some of the, you can see this as all the costs going to the wagon. Who's going to pay for it if all the benefits are going to the operator and the infrastructure manager, for example? So I think, as I said earlier, really today is kicking off the debate. And one of the key things for us is how do we take this forward as an industry? RWA will definitely be looking at this through our engineering committee, but it's obviously wider than just RWA. I don't think I have an immediate answer to him, but I think what we must do is we must get on with this and form our view and make sure it's an informed view.
And from my point of view, I absolutely agree with that. And there are research opportunities in the UK, as well as obviously the shift to rail funding in Europe, which I know Network Rail are still zoned into. But I think if we thought there was some UK work that needed to be done, we should be making the case for that fairly promptly, actually, within the research programmes that we have. But perhaps we can pick that up a bit more as well at the end of the discussion. Right, let's move on. BR had a standard auto coupler from the 70s. During privatisation, the passenger builders started their own systems, resulting in chaos when failures occur. So essentially, we only have one system. I think that's a comment, really, which Steve echoes what you and also John said. The next one from Les, new wagons have a lifespan of 25 years plus. So should wagon owners now be thinking about adding potential costs of retrofitting DAC onto the current cost models? Any thoughts on that one? No one wants to answer a cost one, so let me.
Maybe yes. Maybe a brief answer. If I look over the fence to one of my neighboring work package colleagues on the European level, there is one work package focusing on financing. And a remark given out by the German Ministry of Transport and Digital Infrastructure, maybe 3 weeks ago or 4 weeks ago, at the panel of the German Transport Forum. There they said clearly these already mentioned roughly 6 to 8 billion euros they can imagine to take that, the German share of it. So they are willing to fund this to improve the situation of railways under their responsibility. And we see also the discussion on an EU level that there's a willingness to fund this. The question is if this is a solution for the UK. I'm not sure. But on Central European level, there's a clear picture of yes, we should do, and somehow there will be a public funding for at least some parts of the retrofitting, or maybe some operational disadvantages in the migration during the migration phase or something like that.
And has work done in parallel with that to sort of assess the value of the benefits? I mean, because obviously, there's a big upfront cost here, but in terms of staff productivity, safety, increased loads and stuff, there must be a benefit line as well. Has that been quantified at all? Do we know in the work?
Yes, it's there is already a discussion. Let's say how big the share of the RUs and the manufacturers should be. The discussion is ongoing, but it's a clear picture that this can't be taken only by the rail freight sector by itself.
Okay, thank you.
I think you raise a good point there, Maggie. It's like, what is the opportunity cost versus the upfront cost? Because all of these things will lead to, or should lead to, efficiencies within the systems, and it's how do you quantify that as a calculation? So although the 6 or the 8 billion seems high, that probably isn't what the delta is.
I think so, because I'm reflecting on conversations that we're having about ECTS deployment in the UK and the East Coast programme, where questions like braking curves, how do you know how long the train is, are as yet unanswered, I think. And, we risk a situation where we end up on default trailing loads, which actually undermines the whole principle of ECTS. So, one can already see an alignment of benefits here, and it's good that that's being sort of thought about in the round, I think. Okay, let's move on because the questions are piling in and I'm not getting through them. So let me speed up. Okay, question here from Andrew Cox. If DAC needs to have a rigid height between couplers, would this be an issue of trying to couple a loaded wagon to an empty wagon, as there can be a height difference between the two? Anyone?
Mitch here. The short answer is no. The coupler is designed to gather the height difference, and that's one of the reasons it has to be on a suspension system at the front to hold it at starting nominal height.
Okay.
Yeah. And they're currently running some tests at the testing site in Görlitz in east of Germany. And there they are also testing different wagons with different loading conditions. So one is empty, one is loaded, and then they change. They have a tank wagon where is only water in, and then they empty it, and then they have an empty wagon, and so on. So they exactly check this also. So there's also some material available for that. Who's interested in? Yeah.
Lovely, thank you. Okay, question from Julian Worth in 3 parts. What are the implications for super train operation, max trailing load with DACs? Well, I think, Andreas, you answered that for us at 1.5 kilometres being an aspiration. Julian, second part, longer wagons have implications for loading gauge. Bogey centres determine container dimensions that can be carried. I think that's probably an observation that was picked up around the discussion about deck heights. And the third question is, does DAC require better quality track to keep the couplers level? Sounds like not, from what we've just heard in the last question, I guess. Okay, question from Les Bryant. Would a simplified Buckeye coupling be the answer, with just air connection and minimal electrical connections instead of multiple new designs? And I guess that might be a retrofitting question, which is, if we've got one design for new wagons, is there a simpler version that gets us some of the benefits on the retrofit for less equipment? Question.
It's Mitch here. We can debate that. The coupler will have to have the ability to absorb longitudinal shock, and therefore the space required behind it is essentially the same no matter what the coupling head is like. And then in order to couple with the other vehicles that have been modified to have the DAC, then you would need the same coupling head. So just thinking about it live, it would seem that there would be no advantage. You might as well stick with what you've got. Open to any other view?
Somebody else has asked a similar question, which is, would it be more cost effective for UK domestic fleets to get an electrical supply along a train but use the current coupling and air connections? So do the data but don't do the rest, I guess, is the version of that.
Yep, sounds like a way of moving towards the digital part of the digital auto coupler.
Yeah, okay. So maybe if there isn't an easy retrofit solution on some, we might get half the way, but there are some challenges, I guess. Okay, we've got some questions about locos here. Tim Gabb, we should remember that locos will require modification too, including equipped with EP brake control. And a supplemental to that from someone else, can the current bunch of freight locos, mainly class 66s, supply the 110 volts DC required? Who knows about locos? No one. Okay. Well, I think we have to put loco modification then, Steve, onto your list of things that need to be thought about. Okay.
Yes, I mean, presumably, Andreas, you've had that sort of challenge in.
Yeah.
Germany.
So currently, I'm especially for the class 66, was it? I simply don't know. But most of the locomotive types all over Europe are able to supply this rather, I would say, smaller demand of energy here. Some of them are already equipped with something to do so, but for most of the locomotives, there is still a solution needed. So locomotives needs some very specific solutions, because during the migration phase you need hybrid couplers. So for the locomotives, and we think all over Europe also about connector wagons to solve at least some of the challenges of the migration phase. But on the locomotive side, you need several solutions, and energy is one out of them.
Okay, thank you.
So very good question, yeah, and I'm not aware about the special demands of this type of locomotive, but I'm sure it has to be answered, yeah. And as far as we can see, for the most usual locomotive types all over Europe, it can be solved.
Good, thank you. Okay, comment here from Tim Gabb. The challenge associated with fitting a fleet should not be underestimated. Modified wagons do not appear to be compatible with standard wagons, and difficult to see how it would be achieved without entire fleet modifications. I think, you know, Steve, that was what you referred to as chaos. I can't remember your phrase now, chaos catastrophe. So agreed on that one. When DICs are uncoupled, will a lever still need to be pulled by a person on the wagon? I don't understand the question, but perhaps somebody can answer that.
Yes, I can easily answer this. Yes, at DAC 4, DAC type 5, no.
Good, thank you. Okay, can you confirm that DAC will enable the brake test to be undertaken automatically, removing the requirement to have a member of ground staff to support separation? Or is that again unknown around brake tests?
I mean, Andreas, my understanding is that with the EP brake, you can do the brake test from the locomotive without anyone on the ground. Is that right?
Should be, yes. The idea behind this to run this with a DAC type 4. But the whole benefit you will have from type 5. So I'm not able to answer this for all of the wagons already for type 4, because it depends also on the brake system and the equipment on the wagon, and some of them are rather, let's say, basic, and I can't say it for, or can't answer it for all of them, but in general you are right. Yeah.
Okay, right, we've got a few questions which let me group them together around hazardous materials. So Les Bryant, what's the considerations regarding EMC and electrical supplies, especially on hazard tanks and going into refineries? And then a question lower down, let me just find it. Comment, this is from Andrew Braid. First thoughts of adding 110 volts to a train carrying dangerous goods worries me. Equally, there are safety benefits from having electrical supplies. For example, temperature monitoring and smoke detectors could prevent incidents. Thinking about Drax biomass wagons, incidents of smouldering biomass fuel in wagons could have been detected by means of load space smoke detectors. So I guess that's a comment really around that balance. But any particular thoughts on dangerous wagons or the challenges of having electrical supply? I assume this is, you know, we have them on passenger trains, so I'm guessing we think it's manageable, but
yes. So there is especially there are two experts working only on the data equipment and the energy equipment inside of the coupler and the inside of the wagon. And they are also caring for this question, and I think there are some standard definitions that they have to keep. Yeah? But it is already on the table and under discussion. Not
Okay.
solved yet, I think. Yeah, they have still to deliver all the certificates that this is proven. Yeah.
Yeah. No, I agree. I mean, we have to remember this is early stage research, but you know, I reflect on the fact that in the passenger railway we're talking about carrying tanks of hydrogen around on the train. So I'm not convinced that 100%.
It'd be managed through the CSM process really, and the hazard identification process, and putting relevant mitigations in place, such as compliance with 50121 or EMC, for example. So as you say, I think the mitigations are out there. We'd really just be drawing out the hazards through the CSM hazard identification process.
Okay, lovely. Right, we've got a few questions on costs. So I appreciate the answer to most of these will probably be we don't know, but let me read them out anyway. So from Richard Allen, do we know the cost of a full package, i.e. DAC, EP, brake, wheel sensors, etc.? I guess the answer is we don't yet know. Okay. Is there an example business case? I think, Andreas, you touched on the work that's being done to look at that. So the answer, I guess, is not yet, but being worked on, perhaps?
Yes. So what we can see is very much depending on public funding, for example, for the retrofitting time and the migration phase. This has a big influence on it. In the end, you can say the standard wagon will become a bit more expensive because he has more equipment on it. You might need some more maintenance because there are some more things to be maintained, but in general, it will pay out. Yeah? So once you found a solution for getting from the old world to the new world, in the new world, it will pay itself.
Yeah, brilliant. Thank you. Okay, well, let's see. Can the team say a little more about how the projects, in particular selection of DAC types, I assume, have dealt or are dealing with the Utilities Directive and competition law? It's beyond me. Anyone?
No, it's a good question. I know Steve and I were discussing this last night. I'm not quite sure how you get around that to choose one system when there's 4 companies currently out there. There may be more later, I don't know, but if you choose one, you know, does that mean they license their IP to other people, or, you know, it's a minefield. Lawyers, I think, and people who are involved there.
I mean, I assume like many systems, once you've got a specification, then you can have multiple companies building to that specification, but we haven't got that yet.
I'm just curious, Andreas, I'd heard that the solution was going to be selected middle of 2021, as I said on my presentation.
Yes, right.
Right, because I saw on John's presentation, selection went through to 2022, I think.
Yeah, there will be a pre-selection after all the currently running testings. It is planned in mid of next year. And based on a very transparent procedure which was developed within the consortium for the DAC for Europe, the 6 companies you saw on the end of the short movie we saw, and the lead for this topic, I think, had the Austrian colleagues from ÖBB, Austrian Railways. And they defined, let's say, all the parameters needed to decide upon the right type of the coupler. And currently, we see there are some of them, of the 4 candidates, are matching, some not so much, for several reasons. None of them is really perfect, and we have some iterative loops to go back to the manufacturer and tell them this is not properly working and that. But there's a rather transparent procedure, and in the end, there has also to be decided upon a fairness model, because one of them will have a license then, and the rest is allowed to produce. And this is a legal question, but currently all of them accepted that. And they are following currently a very transparent procedure, which is, I would say, very nice, because all of them know, for all of them, it's a huge opportunity. Of course, one will be the winner, but also the other participants, like workshops for the retrofitting work, also the RUs, they will have an interest in, will I be the first one? Will there be some compensations for early adopters or not? Or what will happen there? So all these discussions are ongoing, and this transparency question is also to be held under the rules of competition law and antitrust rules and so on. Yeah. So this is the legal guys are always standing aside us. So. And
I guess we've been through it on ECTS and lots of other European-wide
yes.
systems where the same thing has happened. Yeah.
Yeah.
Right. Okay. A note here from Liam at Network Rail. NR signed a memorandum of understanding for DAC earlier in the year. Furthermore, we are representing freight at the Shift to Rail Steering Committee. Thank you for an interesting presentation today. We need to further understand what funding UK rail freight have access to. So I think Leanne is, leading the charge here in terms of that NR interface, and we've had some conversations offline generally about that. But just to be aware that we do still have a foot in that camp, despite all the best that our government is intent on throwing at us in that space. Another comment now, which I think we've covered, around the potential of could we retrofit the data even if we can't retrofit the coupler? Question on coupler strengths: what information is given to the driver, and how will the locomotive be dedicated to DAC when the couplers are fitted? Again, a loco question. Any thoughts on coupler strength? No, again, perhaps one to put into our loco pile. How do we think DAC will play in the entirely private sector US railroad industry, where payback on investment is everything? Put another way, how does DAC help us to compete with road? Is this something that's being progressed in the States at all? Do we know?
The thought not.
I'm not aware that it is, but they have the auto coupler anyway in the States, so they kind of have the halfway system. It doesn't have the electrical supply of the data communications, but
I mean, they are fitting digital signalling to a lot of the network, aren't they, to some degree? So perhaps you'd see it as a logical extension of that.
Yeah, I could ask some of my colleagues, obviously being a US-based company, but we tend not to get involved with those guys on the other side. But I can ask the question.
Yeah. Okay. Okay, we'll leave that one till we get towards the end. Should we not define the interface specification in the TSA and therefore allow manufacturers to develop compatible products? I think, Andreas, that's effectively what you're saying is where we would get to in due course.
Yeah, right.
Okay. Les says Buckeye is primarily used in US freight. Siemens, Bombardier, Hitachi, etc. all use different auto coupler systems in the passenger industry using different suppliers, which causes issues when a failure occurs on the network with rescuing units. Same could apply with freight if multiple systems are used or we don't have that interface. I think, yeah, noted. Please, could you clarify if train integrity detection is a prerequisite for DAC or is it a benefit of DAC?
This can be easily answered. It's a benefit.
Thank you. Right, and then I've got some questions in the chat, and then there's one just about next steps, but let me go to the chat and see the people who've posted their questions there. Note, wagon derailment detectors are now available. If you want one, you can get them fitted today. Will automatic couplings apply and release a parking brake? Will ADC facilitate automatic brake tests?
This I already mentioned. SBB Cargo is already doing that with automatic brake tests, and the DAC can enable that. It's not a given feature that is a must, but it's an enabler to do so. So you need the equipment on the brake valve of the wagon. And if you, as soon as you have that, you need also some back equipment to give some info to the loco and to the driver, and then you could use it. Yeah, it's possible.
Could I just say, Maggie, on the derailment detectors, I'm certainly not an expert on this, and I know Les has raised this. My understanding is that the ones we've had to date have been fairly unreliable, mechanical, and they've tended to work by just applying the air brake rather than by sending a signal up the train. And I think possibly that the digital option is probably better than something which just puts the whole brake on. But I see Rob nodding there, so he probably knows more about this than me. But
fine. I think, well, you know, if people want to share more information on what their capabilities are in that space, then, you know, we're always happy to do that as well. So, okay, a comment from Andy Woodcock about loco modifications. I think we've talked about locos. And a comment here from Julian Worth: in the absence of external, i.e. Treasury funding, very unlikely in the current climate, there is a severe risk that this will result in modal shift in the wrong direction to road. Rather like ETCS, it's clearly broadly desirable, but just because it's a good idea doesn't mean we should do it. What's the balance of quantified benefit against the all too obvious cost? So I think we've talked a bit about business case. I certainly can see that there's a lot of benefit. And I think somebody earlier on spoke about lots of benefits that we haven't even thought of what they are yet. And I think that's always the difficulty in a business case like this. But I guess it's fair to say that that's exactly why we need to have the discussion to work out what that business case is. Would that be a fair summary?
yes, and I think the business case in the UK will be different to that in the EU because of the different nature of the business. Far more block trains which don't split and get marshaled. So it will be different for the UK. But yeah, benefits. I understand there have been 3 fatalities in shunting in the last 10 years. You know, the benefits are a huge area, and it needs proper evaluation before we come up to any sort of decision as to whether we as an industry push for divergence or not. And that's the key for us. If we don't have that view, by default, this you know, this change to the TSI will become our change to a regulation.
And it's a very bad look to ask for divergence, not to modernise, I have to say. But I think that brings us on to actually the last question that I've got, which is how do we as an industry decide if we want to go to the DFT to ask for divergence? And I suppose, Steve, that kind of brings us on to next steps.
Yes, it does. I mean, thank you, Maggie. I think we've had a really good morning, one which I think has done far more than just educate us and bring us up to speed. We've heard lots about the challenges, the potential for chaosity was the word, Maggie. And it all looks quite difficult, but as you say, we risk foregoing a lot of benefit and falling behind Europe and the rest of the world. In terms of process, I spoke last week to our SSB about this to say, look, this is clearly a big issue which we need to get on with. I would encourage anyone to perhaps drop me a line or Maggie a line with any suggestions. Certainly the Rail Wagon Association, our engineering committee, as I say, will be pushing this as well. There's the Freight Technical Committee. I don't have the answer here. I think we need to recognise the issue. I think we need to recognise the urgency and come up with a process, but probably not going to solve that this morning. But as I think I said, this is opening the debate. It's a wake-up call, and we need to get on with determining how, as an industry, we're going to take this forward, in my view.
And I think we have some opportunities. You know, Leanne's reflected on the fact that Network Rail are still, you know, part of Shift to Rail, at least for the time being. That gives some opportunity perhaps to leverage some more UK input. We have our SSB who are currently doing the rounds in terms of research priorities for the next few years. This is clearly a space where if we could scope which bit of the UK aspect needed that work that was over and above what we could learn from the European programme, that would be an area. We're likely to get around for Innovate UK First of a Kind funding at some point, which will inevitably cover railways and digital tech in some description. And there are other places where I think we could start to, scope out the threats, the potentials and the benefits. And to me, the key piece is the interface with the digital rail rollout and the ECTS fitment, which we know is gathering pace and seems to be the one bit of the enhancement programme that Treasury do seem to want to fund at the moment, and seeing whether that affords some routes into some prototyping perhaps on some parts of the network as that programme goes forward as well. So I think there's quite a lot to think about from today as well. And I think from my point of view, really, we're prepared to help support that as we go forward with our members and see what the right way forward is. So Steve says, do drop us a note. So I think, Steve, Rob, over to you really to wrap up, I think.
Yes, okay. So I think it's, as I said, it's been a useful session. One of the quotes which really stands out was from Andreas, where he said, this is about the D, not the A and the C. And I think that's where we must focus on the benefits and the potential, as well as seeing how we address those challenges. And I'd like to thank everyone who's spoken. I think it's been a really useful overview of so many aspects of this, and it is really an enormous change for the freight industry, touching virtually every participant. And the challenge for us is how we bring together our view in a fragmented industry that we have here.
Good.
So, thank you.
Okay, thank you. We just got one comment just literally in the chat before we close. RSSB is happy to recommend opening up locomotive and passenger and wagon TSI mirror groups as requested volunteers. Also, RSSB will arranging industry briefing on the whole TSI and NTSN subjects on 8th of January at RDG. And this will also cover interoperability and Brexit. So that comment has come in there from John Barber. So if you want to pick that up from the chat, anyone, you can see that and some dates there. So I think it just falls to me to say a huge thank you to Steve and Rob at Rail Wagon for working with us on this, and to everybody today for their participation and presentations and videos and thoughts. It's the beginning of a journey, but really good to be able to start that. Thank you to all of you who joined us today. We'll have the recording link, as I said, online, hopefully later today. Drop me an email if you want any of the slides. But thank you all very much and enjoy the rest of your days. Thank you.
Thank you.
Thank you. Bye.
Bye-bye.
Thanks, everyone.